Now let's continue this. We have another classification, that is quaternary ammonium salts. They are considered as derivative of ammonium ion which are obtained by replacement of hydrogen atoms. All the hydrogen atoms are replaced, will get R4N positive. Then this class is called quaternary ammonium salts. Here R group can be aromatic or it can be aliphatic. Fine. So they are basically salts. That means some anion will definitely be here. So this is also one class. So here there will be no lone pair on the nitrogen atom. Fine. We have positive charge on nitrogen. Now let's discuss. Further we have structure of amines. Structure of amines. So as they are ammonia derivatives, so their structure is just like ammonia. Suppose this is first case I am taking, it's a primary amine. Then you see the shape of all the different amines is same, that is pyramidal. Their shape is pyramidal, just like the shape of ammonia. But again, due to presence of lone pair, there is lone pair bond pair repulsion. Hence, the bond angle is not the standard tetrahedral bond angle, but it is somewhat larger as compared to that because of the presence of an R group. R group is bulkier in size as compared to hydrogen. So there is steric hindrance between these big groups. As a result, this bond gets apart and the bond angle increases. Though the effect is very less in case of primary and secondary, but the effect is quite appreciable in case of tertiary amines where all the three are alkyl groups. So as a result, there is a larger bond angle in this case as compared to ammonia. Fine. For example, in trimethyl amine, the bond angle is 108, which is 1 degree greater than the bond angle in ammonia, which is 107. This is one aspect. Due to presence of R group, repulsion is there, and the bond pair also, they repel each other. But we know there is one major repulsion, lone pair bond pair repulsion. So that is there. Therefore, the overall bond angle is less than the tetrahedral bond angle 109.5, but it is more than ammonia. In ammonia, all the three are hydrogen, but here all the three are alkyl groups, which are bigger size and bigger hindrance as compared to hydrogen. Now let me talk about hybridization of nitrogen here. This is 1 sigma, 2, 3, and one lone pair is present. So total sigma is 3 plus 1 lone pair, total is 4, which shows the hybridization is sp3. So nitrogen, this is similar in all the cases. All the nitrogens, primary, secondary or tertiary amines are sp3 hybridized. Fine. So out of 4 sp3 hybridized orbital, 3 are used for bond formation and 1 contains the lone pair. Fine. So this is regarding the structure of amines. One more point here, that nitrogen is containing lone pair, so there is availability of electron density at the nitrogen, so it can act as a very good base. We will later on discuss its basic nature. Now next we will shift towards naming of amines. Naming. First of all, I will take up aliphatic amines and I take up their common names. It's very simple. Most of the time we know them from common names. For example, they all are named as first the name of alkyl group and then followed by the name of the family, that is amine. For example, you have primary amine like this one. Here the R group is methyl, so the name is methyl. Similarly, if it is ethyl group, then the name is ethylamine. It's only we should know the name of the alkyl group. Here the alkyl group is isopropyl. So it is isopropyl amine. So this is the case when only one alkyl group is present, and all these cases are primary. Now let me take the common name of the secondary amine. Among secondary, I'll take one example, CH3 NHCH3. Suppose the two groups are same, so the name is simple, it is dimethyl amine. And if the two groups are different, for example this, again secondary amine, then you have two groups here which are different. One starts from E, ethyl, one starts from M. So here we will see the alphabetic order. So it will be named as ethyl methyl amine. Fine. Then let me take some examples from tertiary amines. In case of tertiary amines, we have three R groups around nitrogen. Suppose all the three are same, then it is simple, it is trimethyl amine. Fine. And suppose they are different, for example, two are same, one is different, right? In this case, again alphabetic order, E, these are methyl, N, so it will be named as ethyl dimethyl amine. Fine. So this is about the common name of tertiary amines. Now let me take the common name for some alkyl amines. For example, the most common here is this compound. Now this compound is very important. In all the chapters you will see this group is benzyl. So in case of haloalkanes also, if you have Cl here, it is benzyl chloride. If you have OH here, it is benzyl alcohol. If you have NH2 here, so here the name is benzyl amine. Fine. Then if this is about aryl amine, this is the most important case which will be there throughout the chapter. You will see its properties. Fine. Now let me take up briefly the IUPAC naming. For amines, we have, first of all, let me take primary, CH3, CH2, 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 NH2. Fine. So only one alkyl group is there. This is primary amine. Fine. So it will be treated as NH2 treated as its secondary.